Hey, what is it, guys? Welcome back to a tutorial on rails. Actually, this time we're making some rails and we're moving them in a really kind of smooth manner, in a linear manner as well. You get to choose which one you want. Let me actually show you what this gives us. So if you have a look at the little dotted lines here, the little white dotted lines, those are the rails we create, and on top of it we can add moving objects. So I'm going to show you this one right here. I have a simple line that is really only 4 points. It's really super chunky, but on top of it I have an object that moves in a kind of smooth manner, a Catmull curve actually. I can put it on linear if you wish, and it just moves like this. But what we do is we give the option to actually move this in a kind of smooth manner or in this kind of manner. We also have some more options, just like ping pong effect, so when it's done running it actually goes back in the other direction. It just plays like this. You can also do a lot more with that, just like cameras. I have this camera right here. It's not currently playing, so I'll just play this again. But as you can tell, we have a rail for the camera as well. It moves the camera, it positions the camera. Right now the camera is on linear, so let me just change that to Catmull. And you can feel it, it's way more smooth. And you can have some nice animation going on here. So there's a lot of things. This is in the engine right now. This is not in the editors. You're going to be seeing this in your actual game. And there you go, guys. So without further ado, let's get right into it. Alright, guys, so as always, let's have a look at the current scene. We have a scene with just assets on it. There's nothing else but asset. There is a camera and also some kind of player, but we can't really move it right now because I don't really have any other script to move it. But as you can tell, what we really want to do is have some kind of rail going on in the scene, and then maybe just create some kind of pathway that an object can follow. That object could be a camera, it could be a just a spell effect, could be really anything. You can put your player on that and have your player follow the rail. So let's get started right away. What we're going to need to do is two different scripts actually. We need a script for the rail and a script for the person that moves on the rail. So I'll just go ahead and create a quick script folder on my side. I didn't have one. And then I will do a script called rail. I'll open this up inside of Visual Studio, and now there is a lot of things to do in here, guys, so just bear with me. We are going to code quite a little bit actually, and we're going to start simple by doing linear interpolation, and once we're done with that we're going to move on to Catmull lines. So let's go ahead and get started. So if we were to create a rail really quickly, I'm going to create a new empty game object. Name it rail, move it at the origin of the world, so just in the center here, and then I will create a, say, just a sphere. Again, well, what I'm going to do with this is call this node, and I'll just drag and drop it under the rail, so now it's the children of the rail. I don't need the collider, I don't even need the mesh renderer, but right now I'll just leave it on so I can see exactly where they are. Eventually I'll have to turn this off though. So we've got my my rail, which is at the origin of the world, and then there's this node. What I'm going to do is just place it exactly where I want my camera to go at. So maybe just right about here, then hit Ctrl-Shift-F. It's going to align the node with my view. I'm going to duplicate this by doing a Ctrl-C, Ctrl-V, and say move over here, Ctrl-Shift-F. And I'm going to do that a few times so I can actually have, you know, a rail going on, an actual list of waypoints. And something like that. And we close in by looking at the player, just like this, why not? Okay, so we end up having a rail. Now, right now, nothing really works. We only have like a floating sphere and it looks a little bit weird. But here is what we're going to do. We are going to drag and drop that rail script we've had and just put it right here on top of our rail, our original object, the one in the center. Now make sure you open it, and we are going to go ahead and just draw something in the editor actually. So to use the editor, we'll have to include Unity Editor, and then down here I'll create a function called onDrawGizmo that you gotta be writing this exact same way. And it's pretty much, it's going to be called whenever you're supposed to draw the gizmo. So that's almost every frame in the, every frame you're moving in the scene view is going to call that function. on that function, I'll do a for loop. Now we should do a for loop on every single nodes we have. However, we don't have a reference to nodes just yet, so here's what I'm going to do. I'm going to go at the very top here, do a private transform array that I'll call nodes. And just below that, private void start, and we'll say nodes is equal to get component in children, get component with an S. We're going to get the component of type transform, just like this. And then we can say for int I is equal to 0 as long as I is smaller than nodes dot length -1 actually, because we'll stop one prior, and you'll see why in a moment. And now we pretty much have a space where we can draw in the editor. So what I'll do is handles drop dotted line, and we gotta give in 2 positions. So the first one I'll give is nodes at the index I dot position. The second one is going to be nodes at the index I plus 1, and that is why we stopped one prior, so we don't overflow that array. We also give it a size, so here we go. Now we should be good to go. Let's have a look at this. It does not work, and the reason it does not work is because it really can't find the array. The start is never ran. So to fix this, I'll go at the very top here, do a execute in edit mode, and the start should be ran. And as you can tell, it starts from the very first object, it goes to second one and third, and it just keeps going like that. And something that we might forget though is that they also have a rotation. So as you can tell, the forward of that sphere is looking towards the center. So whenever you're moving your camera, this is going to be something you need to understand. If you want to have the rotation, you need to place your little waypoints looking at where you want them to look, basically. Okay, so that's cool, but we haven't really done anything here. We only drew some stuff in the inspector. What I'm going to do at this point is we're going to create a function to position on the rail, but in a linear manner, so a manner that is really simple. Here's what we're going to do. We're going to do a public vector3 linear position, and here's the parameter we're going to take, int seg float ratio, and that is going to be pretty much it at this point. Now let me explain to you what these parameters are going to be. Seg is going to be which segment you're on right now. So if you are, say, placed right here, that's going to be segment 0. That's segment 1, segment 2, 3, and 4, 5. Now if the ratio is 0.5 and you're on segment, say, 0, 1, 2, then you're going to be placed in the very center of this segment. And here is how we're going to do that. It's very, very simple. We start by declaring a, well, 2 points really. So let's do vector3, p1 for position 1. And that's going to be nodes at seg.position. Now vector3, p2, is pretty much the next one. So +1 dot position. And finally, the return value is a vector3 dot lerp, and we lerp between p1, p2 using the ratio float. And that's really all you need at this point. That's the simple lerp we do. And we're also going to do the rotation just down here. So public quaternion orientation. And for orientation, what exactly should we be taking in? We're going to be taking in the same exact parameters, so in segment and float ratio. And we'll do, instead of doing P1, we'll do quaternion Q1 is equal to nodes seg dot rotation, and just below the exact same thing, but it's going to be Q2 and segment +1. Now what we return is the quaternion dot lerp in between Q1 and Q2 using ratio, of course. So we've got our linear position, we've got the orientation, but those are public field and they're really not moving anything right now. Let's go ahead and just go and create our mover script and just test this out. So I'll right click on script, add a new one, That's going to be my mover. And we're going to have quite a bit of code to write in here before we can actually do something, so just bear with me. The first thing we'll do in that script is create a rail, public rail. So we'll need an instance to which rail are we exactly playing on right now. And now 3 private fields, a private int current seg, private float transition, that's going to be our ratio, and private bool is completed. Now in a private void update, we're going to be using all of these. So let's go ahead and just start right away with a condition. So if we don't have a rail, simply return. We're not doing anything else if you don't have a rail. Now if you are completed, actually if you're not completed, you're going to go ahead and just play. Now play is a function that is not defined just yet, so we're going to go down here, do a private void play, and that's going to be where we move our object. So there's quite a few things to do in here. Let's start by adding up to the transition float. So transition is plus equal to time.delta time, and just for testing purpose I'll do a times 1 divided by 5, which in the end is going to take me 5 seconds before I reach the value 1. Now when I reach the value 1, it means we're moving on to the next segment. Maybe like 3 seconds or 2.5. 5 seconds is way too long. So after every 2.5 seconds, we're moving on to a new segment. At least that's the logic I want to do, and for that to happen though, we need to have some checks down here. So if transition is bigger than 1, that means we're past that segment. So we'll do transition is equal to 0. We're resetting it because on the next segment we need to start fresh, and we'll do a current seg plus plus. Now I'm not going to do the other condition just yet. I'm not going to do like the other checks because right now we might go out of bounds, but I'm just testing this right now. So we'll do the else if statement right away. Else if transition is smaller than 0, that means we're going in the other direction, and we need to go back 1 segment. So transition is equal to 1 because we're starting fresh, but on the other segment at the very end. And then current segment minus minus. Okay, so that's cool and all, but we need to actually move our object now. So at the very end here, I'll do transform, not transition, transform dot position is equal to rel, and then we'll do linear position current segment transition, and that should actually do it. Now let's also do the orientation since we're here. So transform dot rotation is equal to rel orientation current segment transition. Okay, so that's a lot of code. Let's actually just test it out and hopefully nothing explodes. Do we have a mover anywhere? We do not have a mover just yet. We're gonna put that on our camera so we can have a nice feel of what it gives us. So I'm putting my mover on my camera now. For some reason I do not have a reference to the rail. I should have a reference to the rail, and I don't think it was saved. Sorry about that. So the mover here has a field for the rail. Which rail exactly we're using? We're using that one. Let's drag and drop it right in this field. Press on play and hopefully it does not crash, and it seems to be working just fine actually right away. That is what we call a simple linear interpolation. So as you can tell, it's a very simple one because we're just following the dotted line. Now, however, if you have a look at this in the game, so it doesn't look too bad when you're looking at it here. But newer games, what they have is they have some kind of smooth camera. They have some kind of smooth transition in between segment, which we really don't have here. As you can tell, it's really chunky whenever we swap segments, and we also have some errors we need to fix. But that's what we're going to be doing. We're going to be creating what they call Catmull lines. Now Catmull, if I just Google it really quickly for you, is some kind of curves that looks like this, and it's really just a way to have a more smooth movement, and it's really used pretty much used for camera all the time in cinematics, in-game cinematics. That's what they use most of the time. Sometimes they use Bezier curves as well, but I'm not gonna get into that right here. So let's get started. We have a lot of things to implement, and the first thing I'll do is actually go back in my rail, and we are going to create another function right here. So we have the linear position, and this time we're gonna have the Catmull position. So public vector3 Catmull position. This one is going to take in a segment and also a float ratio, same exact thing. And this function is quite a big one actually. Let me just tell you what we need first. What we need for a Catmull curve is we need 4 points. We need a minimum of 4 points. So if we don't have 4 points on our rail, this is not going to work. However, I have some work around that, so I'll just show you right here. I start by declaring 4 points, so P1, P2, P3, and P4. Now we need to assign those, and the way I'll do this is I'll check first, is it our first node? If it's our first node, our first segment, so you're just pressing on play right now, then P1 is going to equal to seg.position. That's fine. Now P2 is also going to equal to that, and you'll see why I do that in a moment. And P3 is going to equal nodes seg plus 1 dot position, and P4 is equal to nodes seg plus 2 dot position. So as you can probably tell right now, we're gonna have a lot of bounds to check a little bit later on. Okay, so the reason I do P2 is equal to P1 is normally the way you actually do it is like this. So P2 is supposed to be where you start, and P1 is supposed to be one step behind. However, if we're on the first node, we don't really have index -1. So what I'll do is I just put the 2 first on the same, and it works perfectly fine. Okay, so whoops. Now let's just assume that we're on the very last segment. We have the same exact problem here. So else if segment is equal to nodes.length -2, really important you put the -2 down here. So if we're on the last segment, then P1 is going to equal nodes seg -1, just like it's supposed to be. Then P2 is equal to nodes seg dot position. P3 is equal to nodes seg plus 1 dot position, and then finally P4 is equal to P3, because there's no P4 at that point since we're on the last segment. Else, and that's a normal way to do it right here. So P1 is equal to nodes seg -1 dot position. P2 is equal to nodes seg, and it just goes on like that for index +1 and +2 now, because we don't have any out of bounds error at this point. Okay, that's a little bit complicated, but at least we've got our 4 points in each and every single case. Now the rest of the equation is a little bit hard to read, and just bear with me for that. So I'll start by declaring some power of 2 and power of 3. So I'll call this one T2 is equal to ratio times ratio. Now T3 is going to equal ratio, T2 times ratio again. And having these guys, now I can actually calculate my x, y, and z all on different lines. So float x is equal to, and yeah, gotta bear with me here, 0.5 f times 2.0 f times p2 dot x. I'm not gonna be saying all of this. There's a lot of things to say here. I'll just try to make sure you don't miss any lines here. So I'll eventually just format that in a way that you can read it. But right now, I'll just copy it off my reference. And that's pretty much math curves. Really cool. at least with this we can have some kind of like nice smoothing at the end, which is better than Bezier actually. I tried Bezier curves, but those are not really what I wanted in the end. But these kind of curves, they really help me have the right feel with the camera. So where was I? P2x minus 3.0. We'll only have to do this once, then we'll do a copy. Don't worry about that. Okay, so something like that. Let me just format this in a way that you can read it. So we'll just start here. And something like that. I think it's going to work this way. Alright, so once you have your X, you just duplicate that for the Y. And also for the Z. Instead of having the .x everywhere, you're going to have the .y for the Y and the .z for the Z. So let me just change that on every single one of those. And here we go. Finally, the Z. Okay, so hopefully I've copied this the right way and we don't have any errors. So what do we have down here that doesn't match? We don't have a return value. That's totally normal. The reason is because we don't have a return value. Now our return value is quite simple. We return a new vector 3 with x, y, and z. And that should be pretty much all we need at this point. If everything was typed correctly, we should now have some nice Catmull positioning. And we're going to try it right away actually, just to make sure we don't go any further with bugs. So I'll go back in my mover script. In my rail, I'll do a Catmull position instead. It's the same parameter, I can just leave it like that and go back in my game. Now I seem to have an error down here. Do I have any error? I don't think I do. So we're going to go ahead and just try to play this now. Have a look at this. So as you can tell, it's a lot smoother. Now the orientation could use some help, but the position at least is really smooth, and you can tell that it's going off the track here. Still having some problem with the fact that it just stops at the node. Yeah, I think we do have an error in our equation though. But it's getting a little bit better. I'll just double check it really quickly and I will come back to you. Alright, so I was right here. We've got an error with the equation. So here is the problem. Right here I've written T2, so this one is a little bit hard to spot. But you're supposed to multiply that by ratio instead. So the first one, the first T2 everywhere is going to be ratio. Now it's the same thing for down here and also down here. Hopefully this fixes pretty much everything. I've also redone the format here, so if you guys want to do that too, it's a little bit more readable depending on how you read code, but for me it's a little bit better, so I'll just leave it like that and just reformat the whole thing. Hopefully you guys are going to be able to read this without any problem, even though I know it's a real big pain to just copy that. Okay, so let me just do that final one and then we can move on to testing this out. And here we go. Alright. This is better. Okay, so hopefully it doesn't still have that little chunky thing going on. Oh, and it does go a lot further on the rail now. As you can tell, this is super smooth. You can't even tell. The only reason you'd be able to tell that you're hitting a waypoint now is because of the orientation. Let's have a look. This is super smooth. This is great actually. Already a lot better. Now what you could do to remove that little effect we just had is you can definitely just take off all the mesh renderer, so you don't really see the sphere anymore. That's fine because you can still see the little dotted line. Okay, so that's cool and all, but we do get an error at the very end. If you guys remember, we get an error because we go out of range, and that's totally normal. So what I like to do is add a few more functionality to our mover. Functionality, just like a ping pong effect. So when it's done doing the whole course, then it starts over again, but in the other direction. And also just having a reverse button, so we can just decide to go in the other direction. That could also be very cool. So we are going to go ahead and just code that, but we'll be coding that inside of the mover. But before we move on to the mover, I'm just going to create another function up here that is going to just call either one of those depending on a parameter. So what we're going to do here is just a public vector3. I'll call position on rail, takes in the segment, takes in a float, and also takes in a play mode. Now play mode does not exist just yet, and we are going to create a enum just at the very top here. So public enum play mode, and we're gonna have the linear and also the Catmull. A little bit later on, if we want to add the if we want to add the Bezier curves, we can also do that. And that's all we need here. So we declare our enum, and in the parameter, we're gonna add play mode mode. Okay, so this function is really simple. We'll do a switch statement would be better if we plan on scaling up. Let's do a switch just to have this clean. So we do a switch on the mode. In case it is play mode.linear, then return linear position seg ratio, just like that. We're gonna break, even though we don't really need to break since we're doing a return. Yeah, let's not break. And sorry about that, I forgot my two dots here. And in case it is the Catmull, we're gonna do Catmull position seg ratio, just like that. And in case it's not able to find any of those, we'll just put default on top of linear, just like this. So in case it's not play mode linear, it's not play mode .catmull for some reason, then it's gonna default back on linear. Okay, now the reason I wanted to do this is quite simple, so I don't have to call these manually down here. Back in my mover script, I'll declare a public play mode. If I can type, I can't type at all. That I'll call mode again. And what we're going to do here at the position is, instead of saying rail.catmull position, is we'll do rail.position on rail, and we'll send the mode at the very end like that. Now this way we can go in the game, press on play here, and have our camera right now in linear swap to Catmull in a second like that. And if we want to go back to linear, we can just choose it via this little menu here. Simple stuff. Alright, so back to what I was trying to implement a second ago. What I wanted to implement is some kind of ping pong effect, some kind of reverse effect. To do that, we're gonna need some public field. We'll start with a public float speed. Actually, we could have a speed. That's very good. Alright, let's do a public float speed, put that on say 2.5 meters a second, and then public bool is reversed. That's gonna be useful. Public bool is looping. Do we want this to loop? And public bool, I'll just call this ping pong. Right, so now to decide in which direction we play, I think I'll just create a boolean parameter here. Yeah, that sounds about right. So in the play, I'll do a bool forward is equal to through by default. Now I've put that by default, but we're still going to be putting is reverse. Actually, is not reverse, because I'm just saying it the other way around. So if it's not reverse, then it's going to write through. Simple. And we can just move forward in the right direction. However, if we are saying that it is reverse, then it's going to say play is equal to false. Not equal to false, but play with the false parameter, and then using this information, we can decide in which direction we go. Talking about direction, the only thing that really affects the direction we're going in is the transition float. If it's going up, then we're going forward, and if it's going down, we're going in the other direction. So all we really need to do is change this by either a positive or negative value depending on which side we're going. So that's sorted out, but there's also one more thing that we forgot, and it's the fact that just assume that we have a segment that is 10 meter long and another one that is 1 meter long. They would be both played at the same exact speed. Even though you're gaining a lot of speed during the 10 meter one, it has to be completed in the exact same time frame, so 2.5 seconds in this case, as the 1 meter long thing. So what we're gonna do is actually try to normalize that, and the way I'll do is by getting the magnitude of that segment. So I'll call this m, float m, then I'll do a rel dot nodes. We're gonna get all the nodes. Can we actually access the node from here, or is it a private? Let me go check. It's a private. I'm gonna put that on public so I can actually have an access to that. So rel dot nodes at the current segment plus 1 dot position minus rel dot nodes at the current segment actually dot position, and we're gonna end up with the vector in between them. Now with that vector we can do a dot magnitude to get the length of it. This way we now have the length of the vector, so we have 10 if it's 10 meter long, we have 1 if it's 1 meter long. Using this information I am going to create a speed value that I'll just call s. So float s is equal to time.delta time times 1 divided by m, so divided by the magnitude times speed. So that's my actual speed here. And we should end up having something really normalized. Now how do we increment that to transition? If we just say s like that, it's always going to be going forward. But if we want to go in the reverse direction, we have to do a minus s. So here's what we're going to be doing. We're going to be doing a ternary operator. So transition is plus equal, and then we check. Are we going forward? Did I write that wrong? It's missing an R. Okay. If we are going forward, then if that's true, we're going to add up s, and if it's false, we're going to add up minus s, just like this. That's a little bit weird. I'm going to format that a little bit better so you can see. Here we go. So this way it should actually work just fine. Let's give this a try. And it might actually crash. Well, it's going to crash again because we haven't checked the bounds, but as you can tell, it's going at a very slow speed, 2.5 meters a second. If we just bump this up here, it goes faster. And if I was to toggle the is reverse, as you can tell, it's going in the other direction now. We could add the Catmull, play around that a little bit, speed it up, reverse it, and we have all the information we really need at this point to create the rest of our system. Alright, so let's have a look at these if. If transition is bigger than 1, then yep, we swap segment. However, if we're on the last segment, so if current seg is equal to rails.node.length minus 1, that's the last segment because of course the array is 0 base and the length isn't, so that's the last segment. If at the last segment we decided we're looping, so if is looping, then we do something. If it's not looping, what we're going to say is simply is completed is equal to true, and we stop here, so we do a return statement. Now, however, if we are looping, we have to check one more thing. So if we're looping and we are doing the ping pong thing, then we are going to just reverse our value. So transition at this point is going to equal 1. Current segment is going to equal the last one, so rails.node.length minus 2, actually this time, not the last one, the one prior to that, because it's the segment. And then finally is reverse is equal to is not reverse. That's only if we do the ping pong effect. Now if we don't do the ping pong effect, it's a simple whoops. That's only if we do the ping pong effect. Now if we don't do the ping pong effect, all we really have to say is current segment is equal to 0. Let's give this a try. Again, I like to just test out things way too fast. It should work in only one direction right now, so only forward. So we're going forward, spinning this up a little bit. I'm going to decide to loop, so we'll just do is looping, see what happens. It goes back at the very beginning here. We'll also do Catmull because that looks better. Now if I do a ping pong this time, is looping and ping pong, it should actually go back from here, and as you can tell, it plays it again in the other direction. If it reaches this point, however, we have not coded this and it is going to crash. let's go ahead and code this. So what I feel like doing is just grabbing this old if statement that we've made right after the current segment plus plus and just pasting it down here because it's really similar. In fact, it's the same thing, we just reverse some value. So if current segment in this case is equal to -1, because it's at this point we're at the segment 0 and then we do a minus minus, which puts us out of bounds, so we have to do something at this point. Okay, so if we're looping and we're doing the ping pong, transition is going to equal 0, current segment is going to equal 0 as well, and its reverse is being reversed, of course. Else we're restarting from the very last point, so that's rel.nodes.length -2. Something like that. Okay, is this going to work? Hopefully everything is going to work and we can have a nice little rail system. So let's play this, increment the speed. I'm going to say that it's going to be a looping and a ping pong effect. So when I reach the end, it should start over again. And it does. Same thing on the other side if everything was coded properly. And it start over again. Now I'm going to remove is ping pong so we can actually just end there and have a look at our character in slow motion. And is that going to work? Everything is working just fine. At this point, your game camera can take over and you can just play around with this. You have a little nice intro cinematic, and that's very cool. Now remember that I've put a camera on this. It could be pretty much anything, so just assume you want to have like a little effect around your player. You can also do that with little effects. Now I don't really recommend that because, you know, the Catmull function was a little bit heavy. I'm not going to lie here. There's a lot of calculation being made, but still you could be doing that around your player. So let's just give ourselves a small example here. I'll create, just say, a effect rail, put that as the children of my player, and I'll just center everything around him, really. Reset that at the right place, and that is the very first waypoint, as you can remember. So let's just move that here, create a empty game object beneath that guy, and also add the rail so I can see it right away. So that's cool here. Move that there and there. Oops. And I'm just thinking about something like that. The last one is going to be on 0, 0, 0, so I can see it again. So here are my nodes. I'm going to remove my component, just put it again so I can see the whole thing. And at this point, this is now rail that is moving with the players, so you can have just a sphere. There's a sphere. This sphere, why not? I don't know where it comes from, but that's going to be the sphere that is going to move with the effect rail in a Catmull pattern. It's going to loop, and that's very it. Let's start. Well guys, you get the idea. So there's a lot of things you can do with that. You put a transform on it and it rotates and it positions itself on that rail that you define. Now there's also a lot of other curves you can need to try out. There's the Bezier curves, there's the quadratic curves. There's a ton that you can code, but right here I gave you mine that I like the most, the Catmull, and also the linear one is just really simple. But I hope you guys enjoyed. I hope you learned something, and if you're going to be using this, please leave me a like, please leave me a comment as well, and I hope you guys enjoy. Other than that, please subscribe, and I'll see you guys next time.